Okay, today we have a demo that we're going to see. It's actually more of an explanation. We're going to have some slides, and we're going to be talking with some people who are real experts in Kata containers. Now, Kata containers is something that I've been interested in quite a bit. It takes this whole idea of VMs and putting them in context with containers. And Kata Container has received some real attention over the past year or more. It's a project that is managed by OpenStack, and it's now in use by companies such as we're seeing, Rust VMM, which is underneath Kata Containers, being used in particular by some of the largest technology companies out there. So joining us for this discussion, we have Ernst, who is a principal system software engineer at Ampere, and Bharat Kunwar, who's a software engineer at StackHPC. Eric is here in Portland, Oregon, and Bharat is in Bristol, England. So thank you both for joining us.
Oh, thanks. It's great to chat.
So Eric, you're going to, yeah, great to have you both. Eric, you're going to get started by showing Kata containers and explaining Kata containers really for us. And maybe you'll show us a few slides. And Bharat, if there's anything you would like to add as we go through this, please feel free. I will add that we'll also, following this, Bharat will be providing more context on performance and some of the use cases and other research that his organization has been doing related to Kata containers.
Awesome. Thanks, Alex. I had worked on Kata containers since it wasn't Kata containers, and I've been very involved with the project. So I'm hopeful that I can shed some light on really what is Kata. In kind of a short phrase, it's an OCI compatible runtime. OCI is Open Containers Initiative. There's essentially a way to standardize what is a container, both from like an image standpoint and also from a runtime perspective. So it's an OCI compatible runtime, which means it's just going to be able to plug in and work just like you'd expect your normal Docker and Kubernetes experience to run. But behind the scenes, it's actually using a virtual machine and then running a container in there. So the main goal of the project is to provide better isolation. Alex highlighted it. It is an open source project, open governance. We're getting help from the OpenStack Foundation for that. For me, it is multi-architecture, which I think is pretty interesting, especially from an ARM perspective now. And also we support multiple hypervisor solutions, really virtual machine monitors in QEMU, Cloud Hypervisor, as well as Firecracker.
Bharat, what gets you excited about Kata containers?
I like the fact that you can run untrusted workloads where you require isolation from the host kernel, host operating system kernel running underneath. So with traditional containers, you have the Linux namespaces, which provide you with like a fabricated isolation, whereas this is, the real deal. Nothing's going to get out.
I hope. No guarantees. It shouldn't. You have a much better likelihood when you use security principles like defensive depth, which is exactly what
defensive depth. What does that mean, defensive depth?
So essentially have two interfaces. If you really have something that you want to protect from a threat modeling perspective, you want to have two different interfaces that have to pass through. So that way you need two pretty heinous CDEs, day zero events, in order to be able to reach the host infrastructure. So right, you're saying kind of some of the idea of container being the softer isolation in a way. And oftentimes when I talk to people about why they like container and everything else, I don't really talk about the isolation side of it, even though that's what we do. It's more of people are adopting it because of the characteristics, of being able to contain all of your dependencies in it. It's just a nice little packaging vehicle. It's a slick UI. It's very easy to just start a container, kill a container, scale up, scale down, everything else. These are the reasons that people care about containers. Nobody is flocking to containers because they're providing isolation. It's more of kind of an afterthought in a way, but isolation can be important depending on the situation. And If, like you were just saying, Brad, it's not a container isn't like a technology. Somebody didn't go to Linus a couple years ago and say, like, here's a pull request for the Linux kernel to enable this feature called container. It's actually just a bunch of pre-existing technologies that are being pulled together in a nice way to be able to kind of give the appearance that you're the only person on the machine. Using things like C groups, you can really dictate how much I/O bandwidth, how many CPU cycles you're getting, how much memory you're allowed to get for a given process. This is something that's existed for a long time already. Similarly, using namespaces, you can make it look like you're the only person on the host, and you can't see what anybody around you has. And same thing, now you can kind of filter and do things like drop-in capabilities. It wouldn't make sense if you're sharing this environment and someone else next to you has a capability to reboot the machine. So they're saying things that you can do to really kind of limit what a process is allowed to do. And same thing with syscalls, you can filter these. So this is kind of a nice amount of isolation. The problem that we looked at, and a lot of people look at around sandboxing, is these are all features based out of the same host Linux kernel. So they all share the same kernel. I consider that to be like the single interface. If you can get root access on that host kernel, if you can do anything kind of to break out, now your idea of isolation is broken at that point.
And that's a chief consideration. And Bharat, what has it been from your experience and how you're seeing containers being used that this becomes an instrumental issue?
Yeah, so in some environments, what you might want to do is run untrusted workloads. So you do not know where the container has been packaged, what kind of privileges have been set as the default privileges for the container. So in those circumstances, it makes sense to run it in an isolated environment.
So yeah, so it's it's a trust issue, which Eric is showing here. And that seems to be kind of an issue that we're seeing with registries, for example, right? Where registries are free to be submitted, and so they can come from any source, and you may not necessarily know what's actually you're putting into your container, into the container itself.
To kind of play the opposite end of it, if you're in a small environment where maybe you and one other person in the same company, you're going through and you have like a CI pipeline that uses containers. This is great. This is fine. If you trust what's going in there, there's no need really to add a second level of isolation. The really use case I look at is all the people making a lot of money doing remote code execution as a service. Right. So if you look at any cloud provider, anyone doing like, here's an automated build service for you. These people, you have to assume that that person next to you is absolutely crazy and wants to break out and get your infrastructure. So, you can kind of look at it as, who's malicious in this case. And maybe we're kind of dividing who likes cats and not. I do. But in this case, the cat could be the bad actor, the person who wants to own your infrastructure. A lot of times when you have like a threat, you're trying to protect something, and you kind of put a cage around that thing. But in the Kata case, we're out to protect the host infrastructure. So if I'm a cloud provider and I give you access to it, I have to assume that you're that cat that wants to get out and rip apart my infrastructure. So I don't trust you. Because I don't trust you, I'm putting you inside of a container that has stronger isolation. So a container that's run with Kata containers. And that's kind of from a threat model perspective, what we seek to do is protect the host infrastructure from an untrusted person or their workload, or both, realistically.
There's lots of CVEs being identified all the time related to traditional containers. With this level of isolation, that you can pretty much guarantee that you safeguard against exposing processes having access to the host kernel.
It's that access to the host kernel, which is the issue. That's
the main threat. Basically, if you look at the model, accessing anything on the host system that you shouldn't have access to is definitely the concern. So it's the whole system. We're just trying to, I don't know how far to go with this cat in the cage metaphor. I think we're about done with it. But I really, maybe you want two cages around this cat in that case, but.
Or it might be like, for example, then that cat might be in the cage, but then there is like a big ferocious dog on the outside, right? So the threat actors can, be, can vary, depending kind of what the danger is as being, that is in question here. And there's all kinds of, there's endless kind of, potentials for threats, right? A shark in the water is a shark in the water, but if you're in the water with the shark and there's blood around, you're in a tough situation.
Yeah, and there's definitely a lot of work going on right now. Different vendors have different ability to, and by vendors, I mean, look at different silicon chips that are available in the market and everything else around trying to do trusted computing. This is where I'm running my workload and I actually don't trust the host infrastructure, which is kind of a different model than what Kata is doing today, but is an expanded threat where I don't want someone to be able to knock on the door at this cloud provider and come in and actually see what I'm running. So if you look at a lot of the different hardware, the memory encryption, and kind of what a trust boundary is and everything else. I think this is going to be a very interesting space over the next couple of years because there's different maturation on what can be done in this space. But.
So getting to the heart of this then, Bharat, I have a question then. So if you think about the people who are thinking about these issues and the trust boundaries changing, what trust boundaries have changed already to force a company that's a major cloud service provider, for example, or a chip company to think about the architecture developments that are needed? What are those changing trust boundaries really? And how is that affecting the companies out there and the people who are designing like infrastructure architecture?
I believe there's hardware level encryption which is being pandered at, but I think I'll pass this one to Eric. Being from Intel, you're probably better qualified to answer.
With the move to containers being so popular, there's probably a lot better resource utilization that you're going to get on servers and everything else. So there's kind of drive to that space. And how can we, instead of needing to say, you want to run a container workload, wonderful. Here's a virtual machine. And now on that virtual machine, you can run your workload. Instead of doing that, being able to better bin pack and directly just run the workload, assuming that you have strong enough isolation to be able to trust it is a goal. And I think that the whole trusted computing is a bit of a newer space as far as it being more accessible. And this is probably just the drive to the cloud, of cloud computing versus enterprise. Like cloud is just growing. It surpassed everything else. And now people are starting to say, all right, it doesn't make sense for me to run my own data center. I'm going to use the cloud, but I have some sensitive documentation. Maybe it's an algorithm that I don't want them to have access to. Maybe it's HIPAA records. Maybe it's I'm doing something nefarious and I don't want the government to see what I'm doing, right? All of these things kind of get into this space of what if I don't trust the person who I have running my code? What is feasible then? But I think that that's one, it's not something that Kata can do or focuses on today. But I think that over the coming year, 2 years down the road, as more of this is figured out in the ecosystem, that this will become a popular area. But to be clear, this is looking forward, I would say.
I just wanted to add that the metaphor of TLS certificates is relevant here with services like Let's Encrypt making many websites on the internet use TLS endpoints to encrypt web traffic. There's root certificates that people trust being distributed in hardware that manufacturers making, which can then get inherited all the way through to the processes running on these machines. That's one concept that I have come across in this space.
So going, with that threat model understood that what we're trying to do is protect the host infrastructure from anyone's workload. That is essentially the motivation for what Kata is doing and to provide that second level of isolation. So containers are great. They do a lot of, as a first base layer of isolation. So we still run a container. It's just that we do that within a virtual machine. So Each container or pod in the context of Kubernetes uses its own kernel, and it's the guest kernel that's running inside of a virtual machine. So with that, now you have a second level of isolation, which is the actual hardware virtualization interface in the operating system. It's not that, we're saying virtual machine isolation is better than container isolation. We're saying that you should actually use both. If you are running in an environment where you can't really trust what's running around you. Really kind of like along those lines, the snazzy tagline, everything needs a tagline, is speed of containers, the security of VMs. I don't love it, but I like to keep it in here because I can say how I don't love it. It's not the security of VMs for what I just said. VMs are fine. It's much better than the security of VMs. We do quite a bit to constrain the potential malicious workload by putting in a container. We have a very minimal guest kernel and a very minimal root-fs available for an attack surface. And then that all is running inside the virtual machine. You're still sitting behind on the host infrastructure. Speed of containers is also a bit open-ended. What does that mean? Boot time? Like how much do people care about boot time? I'm not sure. Or could it mean actual I/O? What is your file I/O? What is your network I/O? And what does that speed need to be in order to be able to how do we mitigate that so that way it's fast enough so that way you can run your workloads efficiently? And I think that this is an area that Bharat was looking at.
Yeah, Bharat. Yeah, I was going to ask Bharat, what are some of the trade-offs here?
With Kata, when I first started playing around with it about a year ago, it had the virtio sort of 9PFS based IO backend, which basically assumes that it's basically a network based file protocol. With that, the performance wasn't that great in terms of doing lots of IO, in terms of running IO workload. However, more recently, Kata now also supports the virtio-fs driver, which basically takes advantage of the fact that the disk is co-located in the VM that it's running in. So as a result, it's considerably faster, especially if you also have direct memory access enabled, which further increases performance. But neither of those cases as fast as running bare metal or in run-C containers. But this is specifically for looking at the disk IO sort of use case. It's not looking at anything else.
Looking forward, the real key is that it's a drop-in. You don't have to change your workload. You don't have to change how you use your infrastructure or anything else. So if you're using Kubernetes, if you're using a Docker or maybe Zen or any of these things, if you are used to using run-C, which is the canonical runtime underneath, Kata will behave the exact same way. And I want to kind of show just a brief look at how does this actually integrate with Kubernetes on a node perspective. So you have a cluster. Looking at your node, you're going to have kubelet running, which in Kubernetes, this is just the agent that is sitting there and polling at CD or in the API seeing what jobs am I supposed to run. And make sure that if I see I'm assigned a job, I'm going to start executing it. And it'll say, pull the image for this workload, everything else. But it's actually going to do this through a container runtime. And I'm going to say container runtime 7 times, and it's going to mean 4 different things. And I'll try to clarify. It's very overloaded. Basically, kubelet used to pretty much just use Docker shim. And a lot of people had the idea of, that's not really optimal. I want to be able to create my own runtime instead. And it kind of forced them a few years ago to define the container runtime CRI. And as a result of that, there have been a bunch of projects which have started, including Containerd and Cryo, that implement this CRI interface. So when kubelet says, pull this image, it's actually Cryo or Containerd that are going to do this. And when they say start the workload, it's actually not even Containerd or Cryo. They're going to continue to one level of abstraction down, call the actual runtime engine, or the OCI runtime, I would say. And the canonical solution in the ecosystem, like the out-of-the-box default you'll see everywhere, is going to be run-C. What these actually do are they create those namespaces, they create those C groups, they actually put the image inside of it and then start execution. Kata runtime is another equivalent of that. And how the cluster is generally set up is on a per workload basis. So for like every single pod, you can specify explicitly as a user, or you can set up a policy from above to say that this workload should run with this runtime class. So that's a key value pair that says on a given workload, whether it should use runc or kata. You could say whether I trust it or I don't trust it. And you would use the corresponding runtime. And what each of these runtimes will do is, in the case of runc, it'll just use namespaces, C groups, capabilities, and it'll start up, let's say the description was busybox in PHP. If you're using kata and you kubectl apply, what you're going to get is you'll actually create a virtual machine. Inside that virtual machine, a pod will come up. Same thing if you want to use QEMU. I'll kind of show, but we support multiple virtual machine monitors. So underneath, all this is happening. But from a user perspective, it's the same process. You see that you have a container running. You can do container stats. You can look at everything. But actually, we're creating a virtual machine and putting it in underneath. The only way you would really know is if you start snooping around that particular node's file system and you see, hey, what's this process going on? Why do I have Firecracker process running in things like this? So a lot of the work that we have to do on the Kata Containers project is taking these like fundamental concepts of like, hey, you go run a container, to make it so that way we do run a container instead of a virtual machine and nobody has to know about it. So like, I think Kelsey Hightower is always like, we're just all plumbers and that's all we're doing. And that's what we're doing in the Kata project. We're trying to map these concepts of these are, I assume that we have a shared file system and I assume that we can do this. How do I map that from a user experience perspective to be no different, but to actually be able to utilize a virtual machine? We don't actually want to look at this, but to kind of have the idea of what does this mean? You have that CRI defined interface. It means that there literally are, you must support these various functions to update a container, start a container, create a sandbox, all these different things. We have to implement that. And if you look at a native container, these things like, all right, make the namespace, make the C group. We have to do a lot more than that. Those, in order to make that API, we have to kind of have these fundamental concepts and technologies. We need a gRPC. We need a way to communicate with something. We need to create a network interface. We need maybe mounts if we're doing volumes or secrets or config maps. We need to be able to update the size of the container if we do vertical pod autoscaling. All these kind of concepts come together, which kind of map to some traditional VM technologies. You need a virtual socket if you want to talk with something. You need virtual storage. You need a shared file system. You need device assignment if your workload, maybe you want to pass a GPU. Things like this. And that comes to actual devices inside of a virtual machine. And ultimately, it comes to, you need a virtual machine monitor or a hypervisor to be able to kind of provide these base APIs. And when it comes down to it, not each VMM supports all of these. And for good reason. There's a lot of, look at Firecracker is a great example. Firecracker's QEMU is a very good separation. Like, they're very different is what I'm trying to say. QEMU is designed to support anything in quite a bit of use cases. So like device assignment, everything else, like it supports running a virtual machine. Like I have a full machine. I have all these different devices associated with it. Firecracker, they don't want to be a virtual machine as much as possible. They have like 2 devices associated with it. So VFIO, which is how you do direct device assignment, not supported by Firecracker. File system sharing, definitely not supported by Firecracker. Hot plugging, updating resources, definitely not supported by Firecracker. Because what we're looking at is they are looking at solving a very focused problem. So they don't need these technologies for their problem. Their problem would be, let's say, function as a service when you're looking at Lambda. Or maybe it's kind of a very narrowly focused how to run containers, where you don't need to do direct device assignment. There's a lot of discussion there around cattle versus pets and things like this, but basically they're looking for short-lived ephemeral workloads, and they just want to support those. They don't care about GPU assignment at this point or file system sharing, because each of those things is footprint from like how many of these can I pack into a single machine, as well as attack surface. So It's pretty interesting. I think I really appreciated being able to talk a lot with the Firecracker virtualization team and understand kind of the ethos of what they're doing. And they came from a standpoint of, we will not support anything until we absolutely need to and completely have the threat model at a state that we're going to accept. So for that, if you're in a situation where you want to use Kata, and let's say you have function as a service, and you know that you don't care about device assignment or any of these things, then it's a perfect solution. But if you are looking to be able to run any workload that also has devices, or maybe has file system sharing requirements, which is actually very, very common in generic Kubernetes, then it won't necessarily work. So I would say that they're at the kind of two ends functionally. One thing interesting about it that we talked about before is that Firecracker is actually a fork of CrossVM. And it's written in Rust, which if you want to be secure, you have to write everything in Rust now. And there's been a really awesome community growing around this whole Rust virtualization area. And I would say it's Rust VMM is the community. And you have people from Google, you have people from Amazon, you have folks from Intel, and a whole slew of other companies as well, I think Ali as well, who are very interested in kind of figuring out how can we have something like Firecracker is one implementation of Rust VMM. Can we make other implementations that are not focused just on function as a service, but are more generic, like wanting to run cloud workloads? And that's kind of what the third option on the top is, Cloud Hypervisor. So for Kata Containers, we support all of these, and it's very hard. You know, sometimes I get a question of which should I use. Firecracker is very popular. Like, hey, it's a micro VM. You got to use micro VMs. You're stupid if you don't use a micro VM. But it really depends on your workload. If you can be narrowly focused and you don't need some of these other assumptions, then that's your best bet for sure. But if it's not, then you're going to need something more fully featured. And I'm personally very excited about the work that's getting done in Cloud Hypervisor, because I think it's a more natural fit in Kubernetes itself.
Who's behind Cloud Hypervisor?
So a bunch of people over at Intel. When I was over there, they're the primary. I know that there are a lot of other contributions as well. They just kind of are working on pushing it out, but they see it as an example implementation of the Rust VMM ecosystem. So it's kind of a mix, like where indirectly you'll get anyone contributing to Rust VMM is also contributing to Cloud Hypervisor. But at this point, I think it's predominantly Intel, but I know that there are some engineers looking at adding ARM support, for example, which I'm excited about.
When I first came across Kata Containers, I was told that things like host networking concept in Kubernetes is not supported. Is that still the case, or has there been some kind of workaround at this point?
Not really host networking, no. That one is still kind of a set limitation. But you know, for each of these, if you were to look at it, you know, there kind of is some inherent, you can do this, you cannot do that. And part of this is to be explicit that, like, it's not a gap intentionally. It's just that we choose not to do this because not everybody needs to do vertical pod auto scaling. Hardly anybody needs to do that. So don't support it. You can simplify your design quite a bit. Perfect. Secrets, config map, volumes, that one's a challenge. A lot of Kubernetes kind of assumes you can do this. So that's more important. But again, device support, this is not as many people are assigning accelerators to a given container workload. So I think that's a fine trade-off as well. As I was saying, we end up running a workload inside of the virtual machine itself. So on your host, there is a binary running. It's called Kata runtime. And it is what's going to interface up with a CRI implementer or Docker even at this point. So, you know, we receive and manage the commands for creating and managing the lifecycle of a container and pod. But in actuality, what we do is we start the virtual machine, a minimal guest kernel boots up, and the init process on that virtual machine is an agent. And that agent's job is kind of like what runc would be on the host itself. So we communicate with that over gRPC. But basically, you know, we have a couple of interfaces then. We start the workload. We if we support the VMM supports it, we would pass in volumes using virtio-fs, which is what Bharat was discussing and highlighting. Similarly, networking gets piped in. We use NAC VTAP, and it'll be a virtio-net device passed in. I think that this is good to show because, as we look forward on Kata containers, each of these devices that we require, you can see that we have this VSOC device, we have this network device, we have this volume file system sharing device. Each of those I would look at as attack surface. And if we don't have to use it, it's much more secure. If you create a box and don't have any holes into it, you can't really do any work into it or out of it. So chances are that's not necessarily going to work and be realistic. You can make it really secure, but it doesn't do anything. We are looking at, in particular scenarios for hard multi-tenancy, a lot of different end users are looking at, what if we don't do any volume management or image management on the host and instead do it inside the virtual machine itself, which is something that we're looking at changing for Kata going forward. But this is kind of, if later we want to have a discussion, this is a good diagram to come back to. This is kind of looking back over the last 2 years or so. 158 different contributors, 27 different organizations. I was at Intel before, and when I was there, the number one goal of mine is to try to not work on it and have to have other people contribute to it, just from a sign of health of a project. If you look at the ecosystem, you don't really want to work on a project that isn't supported or isn't interesting or maintained or any of this. And having a diverse contributor base, we have a lot of different cloud providers, a lot of different people who are running services who are very interested in Kata containers, as well as all the different major vendors contributing to it. So I think that's the last bit that I would highlight as far as, what is Kata and really who is Kata containers.
So Bharat, would love to kind of get your perspective on Kata containers. Perhaps you could provide some perspectives here. And I think Eric's just ended here with some of the common use cases that we're starting to see: functions as a service, pipelines. Maybe you could, shed some light on what you're seeing in the Kata container ecosystem and what's of interest to you.
Sure. So I can talk a little bit about the performance benchmark study that I did sort of between last year and December. Well, yeah, most of it last year, beginning from May up until December, when the development was still happening in the background for Kata, in the Kata ecosystem. But there was a new feature announced with regards to the support for virtio-fs. So yeah, I'm just going to be talking about the disk-I performance of Kata containers. So this is with regards to the interaction with volumes that are mounted into either mounted or not mounted into containers. So what happens when you try and write to a disk, whether it's a network parallel file system or whether it's a volume that's mounted into a traditional runC container versus Kata container with the old or older sort of virtio 9p interface, and with the new virtio-fs interface, which has been available since. So yeah, one consideration for Kata, which I don't think was mentioned, was it requires nested virtualization, support for nested virtualization. This is how you would be able to check.
It should only need nested virtualization if you are running within a virtual machine already, right? So in a cloud environment, 100% needs to be nested, but you can also run bare metal, which is optimal performance-wise, but again, in a cloud environment, it's not always feasible.
What is nested virtualization?
VM in a VM, basically,
okay.
Usually it requires hardware support. And that's the excitement of virtualization is the tables and everything else are getting mapped and shared. But as soon as you now run a virtual machine in the virtual machine, you have to emulate some of that. And there's a lot actually of work. Nested virtualization used to be a very interesting skunkworks project nobody cares about. I think at least 2 levels of nesting is a lot more common than you would think in the cloud now. And there's a lot of work in optimizing this at this point. Even like having like KVM on Hyper-V, like that's a huge model right there.
So yeah, if you're running Intel chips, you need at least the Westmere architecture, which I found out because I tried to run this on a cloud provider which had nested virtualization support, but the chip was too old. One of the considerations is the virtio 9P and virtio-fs. So 9P is based on an existing network protocol, which is not very optimized for virtualization use case. And virtio-fs, which has been available since 1.7 release of Kata, it takes advantage of the fact that the volume is co-located with the hypervisor. Basically, what that means is that it tries to cut out as much of like the middleman as possible in order to give you high throughput when you want disk I/O. And also with the virtio-fs, there's a direct memory access mode, which basically maps the content of the file into RAM and gives the guest direct access to the data on the host page cache. So basically, it reduces the memory footprint by allowing the guest to share the same memory space as the host. But yeah, I'll show you some results in a sec. So these are some deployment instructions which I can share with you, and it's freely available on GitHub. And this is our test apparatus. So basically, we had Kubernetes master node and 2 worker nodes, all with 32 CPUs and 125 gigs of RAM. The parallel file system we deployed was virtio-fs, NVMe storage backend over 100 gig InfiniBand. At the time we ran this, we were using Kubernetes version 1.16, which is 2 releases prior to what the current latest is. We were using Kata version 1.9.1, and I think at present it's at 1.10, remember correctly?
Yeah, that's correct.
Yeah. So, well, one of the challenges that we faced early on was that BGFS and virtio-fs did not cooperate very well. So we had to make some changes to, so basically it's to do with the syscalls instantiated by virtio-fs, and the underlying BGFS file system, it wasn't able to execute some of the syscalls. So we basically had to make some changes to the code to kind of ignore this, because it wasn't actually causing any, it was just an additional unnecessary check which wasn't required. Also, another issue we faced was that we were using CentOS and virtio-fs that comes shipped with Kata. It requires a much newer host kernel. It didn't support the latest for CentOS, which is CentOS 7, which is 3.10. So we had to rebuild the virtio-fs binary in order to make that compatible. And yeah, thanks to the folks from virtio-fs dev channel.
So I guess the question comes down to it is, you know, there's definitely, we were talking about nested virtualization and, running on, on the Westmere processor. But what is the usage like? We have one question from Alexis Richardson, who is with Weave Works, and he was curious on how does Kata help developers? How many are using it? Really, what's the story there? Really the same for the enterprise, on practical examples around how it's being used, and and I'm curious, what your response is to that from each of you, really.
That's an interesting question. I think that for developers, I'm not as confident in saying developers directly, other than this is more boring technology that is supported by every hyperscaler out there. Everyone who has a large cloud service has something just like Kata running. It's either is Kata or their version of it. And what we're looking to do is make an open source version of it. So an end developer, isn't so interesting at how does Atlassian run their pipeline service, right? They're using Docker and all this stuff that's very dangerous from a threat perspective. So in that environment, they need some stronger isolation. So they look at something like Kata and say, this is a perfect solution for us. So rather than hitting the developer directly of, I want to install this on my system and start using it, this is more of a lot of the tooling that I use, unbeknownst to me, actually uses Kata. So I use this build pipeline service, and that is helpful. I'm glad this service exists. In order to provide that service, that cloud provider needs something like Kata or is using Kata. So I would say that that's really where it hits. And, for enterprise, there's a lot of activity in this space. I'm not sure that I have much to comment specifically on that. But again, the main users of this are really cloud providers. People who are doing containers as a service or some kind of pipeline as a service or want to help with container building, things like this.
Well, what are we looking at right here?
So yeah, we at StackHPC, we got interested in this from the perspective of running HPC workloads, untrusted HPC workloads. So here, what we're looking at is the bare metal, the comparison of how much read bandwidth you get for bare metal case versus runC versus with the Kata with the 9pfs, Kata with virtio, and Kata with DAX. Basically, the question we wanted to answer was, what is the trade-off of using Kata containers versus the traditional runC? And as you can see, there isn't a whole lot of difference between bare metal and runC as you increase the number of clients. So basically the number of processes which are trying to write to a parallel file system volume all at the same time. So on the left-hand side, we can see a case with a single client. In the middle, it's a case with 8 clients. In the right-hand side, it's a case with 64 clients. And runC sort of closely follows the performance of bare metal, which is kind of the reason why containers are, the traditional runC containers are so popular, I guess. And when we first looked at Kata, which was back in May 2019, this was the only scenario that we were able to examine, the Kata 9p. And it wasn't doing so well compared to runC and bare metal. So as you can see, with the increasing number of clients, it doesn't really scale all that well. And the 4th and the 5th blocks, those are the cases for virtio and virtio DAX. And in this case, as you increase the number of clients, it's better than 9p for sequential and random read cases. With the virtio DAX case here, it's a bit weird because it's writing directly to the guest memory, and not all of the synchronization has quite happened yet. The performance looks like it's vastly exceeds the bare metal and runC case. I don't know if you have anything, any comments to add to this, Eric.
Not specifically about how wonderful or how interesting, rather, that particular line is, but commenting on 9p itself, for how we were using 9p, it's horrible from a performance, from security, and from functionality.
What is 9p again?
So 9pfs essentially is a neat way to be able to kind of share a file system with across a network, let's say. So being able to pull different information from a different machine locally, which it wasn't really designed to be a full file system. And at the time of starting and working on Kata, it's like, okay, you shouldn't use something like 9PFS, you could try to find an alternative and use block devices, things like this. But if you need to, just to show compatibility, we'll add it. And it has a lot of issues around POSIX compliance. So, different workloads would maybe do different symlink and different things, and you would end up running into issues. So what's really nice is Red Hat has taken a lot of interest in Kata over the last several months to a year, and a lot of developers came together to make virtio-fs, which is essentially designed from the ground up to be able to share a virtual an image, a file system with a virtual machine running on that host. And when you look at the Virtio DAX mode, the Bharat is showing here, this is exactly like, this is, if you were to use Kata, this is a configuration I would recommend. You are sharing, if you need to do file system sharing, you have a block of memory that you share between the guest and the host, and that's how you pass it through. And that's going to be optimal from a FIO performance perspective.
Yeah. So similarly, this is for the write case. So on the top, we've got the sequential write, and at the bottom, it's random write. And as you can see, the performance sort of scales similarly to bare metal and runC when you're using virtio. In fact, even the 9PFS is not doing too badly here. And here for 64 clients, it's the 9PFS even seems to exceed the performance of bare metal, runC, virtio, and virtio DAX. This is my observation. I do not know why this has happened necessarily, but in the case of random write, with fewer clients, virtio and 9P don't do so badly, but when you have when we scale this all the way up to 64 clients, even virtio and virtio DAX seems to suffer from performance penalty. These particular simulations were taking very, very long time to complete. It took me days to get these results. But yeah, but it would be interesting to hear your thoughts on why this is the case.
I would look at, I think using FIO and being able to really pinpoint, what that gap is helpful. And the next step is looking at virtio-fs and understand what's going on between the daemon on the host, the shared memory region, and what's actually being done inside the guest kernel itself. But this isn't my area of expertise. I would say that, again, the very talented, great virtualization group at Red Hat has been doing a nice job contributing here. And I'm sure that, this is something that I offer and recommend for Kata containers when a shared file system instead of block-based is required. And it's already way better than 9PFS. And that's the reason I personally felt very confident in saying that this should be the default going forward on Kata containers. Having said that, the bar is pretty low. 9P is pretty horrid, again, from all perspectives. So there's a lot of work in this space in optimizing this and moving it forward. And I have a lot of confidence in the team that's working on it. So.
Yeah, I'm just curious on, how could compatibility be maintained with Kubernetes, and what are some of the architectural changes that are coming?
So as a Kata contributor over the last 6 months, I've spent a lot more time actually working the Kubernetes ecosystem itself. And we really fit in around SIG-Node, I would say. So there's a couple of things going for us that makes life a lot easier. One, people care about security now. This wasn't necessarily top of mind to do sandbox runtimes a few months ago, or a couple of years ago, really. So as far as the standards themselves, they're being kind of written to say, okay, how does this impact Kata containers? How does this impact other sandbox runtimes? Similarly, like if you look at gvisor as well, both of these are no longer kind of like a weird project anymore. They're much more standard and used in production. And as a result, we are often pulled into conversations and to make sure that different features that are getting input into Kata, into Kubernetes, do not negatively impact Kata, rather than the old days where we would just upgrade to the next version and everything would be broken and we'd have to figure out, okay, how do we fix this? How do we still be compatible? So I think standardization and being involved in the community.
Bharat, any last thoughts on your, on kind of what you'd like to see out of Kata containers, and what are some of the things you're following going forward?
Yeah, so I work on, I contribute to OpenStack Magnum project, which is for managing the life cycle of Kubernetes clusters, but also with integration with other OpenStack concepts like load balancers and block devices. Yeah, we've recently added support for Containerd and consequently and accidentally also added support for Kata, because anywhere that supports Containerd also
Right.
is able to run Kata. So I'm excited that Kata is gaining widespread momentum, and especially with improvements to the disk I/O performance that I was able to demonstrate. I think the adoption's going to get, hopefully the adoption's going to get even further.
Excellent. Well, I want to thank you both for taking the time to talk with us today about Kata containers. I've been joined by Ernst, who's a principal systems engineer with Ampere, and Bharat Kunwar, who's a software engineer at StackHPC. Thank you both for joining us.
Thanks,
Thank you.
Alex. Appreciate it.